Hey, it's Matt Erman. I'm author of Grokking Software Architecture by Manning. Senior engineer at Blackboard. It's an ed tech company. So I had a pretty interesting start as a software engineer. I didn't actually start until I was around age 30. So I kind of was a late bloomer in terms of software engineering. And I actually kind of got into it. I kind of look back and it's almost like one of those things that it seemed like it was just meant to be, just meant to happen. I had a random encounter with a person I was working on a football game with. He was working on a football game, and he's a software engineer. He's actually a principal engineer now. And essentially, I was working to help, do some stats and stuff for him and get you know, some research and things like that for him. And we were talking as we kept talking more and more. He one day just asked me, "Is like, have you ever thought about becoming a software engineer?" And I'm just like, "No, not really. Why?" And he's like, "Well, I think you'd be really good at because you think like one." And so he's like, I'll help you if you want to, look into it and, see if that's something you might be interested in. So, I started doing a little bit. And I mean, when I started, I didn't even know what a variable was. Like, I was like completely starting from nothing. Like, I had no idea about anything. And yeah, it's just the more I did it, the more I loved it. And the more I loved it, the more I wanted to do it. And, it just kind of snowballed from there. And then, yeah, I kind of look back now and it's just like, how did this even start from where I was? Because it just, just one of those things you look back and say, like, if it wasn't for this situation that happened, like, where would I have been type thing. And so, yeah,
Yeah,
that was,
because your friend was very right, for sure.
yeah, I kind of joke with him now. I'm just like, yeah, it's like, I couldn't imagine like where, how this turned out. So, but yeah, here we are.
Yeah, good, good, good. And from there to now, so I don't know if you ever thought about writing a book or you saw yourself writing a book, but here you are. So I guess you learned quite a bit
Yeah.
from since then.
Yeah, it was I didn't it was funny because like when I was in high school, my English teachers were always like, you should think about becoming an author because you're a pretty good writer. And I was like, yeah, right. Like whatever. Like I have no interest in really doing it. And then um, it's more just I saw an opportunity where I didn't feel like I felt there was a hole in the market because I'm sure you probably seen this too. You graduate from computer science, you get a degree in computer science, and then you go to your first job, and what you learn in school versus what you're expected to do at your job is like a giant gap between the two, and there's really not much that fills in that gap. It's always it seems like the books that are written are always for once you learn how to get to this level, then you can start reading books and, stuff like that, and it'll help you, progress even further. But I didn't really feel there was books that really spoke to how to get from, just starting out of school to where you need to be starting a job and what they expect you to know. And especially these days, with everything, the cloud and everything else that's included with what you're supposed to be doing on a day-to-day basis. What you need to know is seems to ever to be always increasing, and so I just felt the gap was increasing a lot because we do some mentorships at work with some of the younger developers, and some of the stuff that I was asking, they didn't have very good concepts on basic foundational stuff, and so I just felt like that things probably were like, and I started reading some LinkedIn posts and they were, kind of parroting the same things I was seeing. And so I'm just like, this is probably a problem across the industry. And then so, you know, I felt that, maybe there was a market for a book that was written directly into that framing. So, and turned out that it was pretty well received. So,
Good, good. It totally makes sense, and even more nowadays. We are on July already, yeah, 4th, as I see, and 2026. So I guess, yeah, that's meaning that because we are already, maybe this for our future self in the AI era.
Yeah,
So all those youngsters or people that are starting, they sometimes they don't need to understand so much to produce something that somehow works.
right.
It's
That's
big
that's
difference.
the danger of it, though, because
Exactly. I think that,
getting something to work is not the same as, having something that's ready for production or that should be in
exactly.
production. Those are
Yeah,
two
yeah.
different concepts.
I think that one of the difference between being a senior or not being a senior, right? I don't know the role, but to have the experience is that the how little you trust the work you do. The more experience that you have, the more suspicious of the work that
Yes.
you do you become, I feel.
Yeah,
Um,
definitely.
and yeah, okay, so maybe I guess to maybe a question that it must be asked is that since you wrote the book Grokking the Architecture, or so what do you think, or how would you explain what architecture is, understanding that there might be many angles to.
Oh yeah, I'm sure there's a lot of different, viewpoints, and there's probably more than one correct answer. But in my view, I think oftentimes people tend to look at, it in a lens of, oh, what's the cool thing to work with, or what's the new JavaScript flavor of the month type thing, and I want to work in this, or and it's essentially what you're wanting to do, I feel, is that you pick the best tool for the job. And so, if you're building something like a game or something that needs to be super fast and whatever, you're probably going to look at something like C++, or you're going to, but you're basically choosing the proper trade-offs for what you're wanting to do and the requirements that you have in the business, and the constraints that you're working within. So, if you have the business gives you 3 months to do, or 3 weeks to do something, produce an endpoint that works and is able to, work for 100 users. You're not going to probably build something that is perfectly scaled for 1 million users, that has everything under the sun that you'd want to put in there as a properly scaled system. So sometimes the proper architecture is doing what's optimal for your solution, that the constraints and the business requirements you have to work within. So um, I think there's always an interplay there where as an architect, you want to do a little bit more than probably what you have the time for, what is required, and you're always looking to the future. But it's kind of a double-edged sword where you're, sometimes you try and optimize for days that never are going to come.
Yeah, or abstract a bit
Yes,
too much, be
exactly.
more flexible. Absolutely. Sounds good. Sounds good. Sounds like yeah, an insightful description for sure. And yeah, I remember reading on your book the one way to codify these trade-offs that you talked about, and the requirements is these ADRs, architecture decision records.
Mhm.
I was curious because, yeah, as such, I think I haven't encountered them, but maybe some. I wanted to get your take on that. If how you use them, maybe,
Sure.
um,
We
maybe the
actually
different.
use them. We actually use them quite a bit. Um, that was actually one of the first things that I was really happy with when I got to the Blackboard. Is that our team uses them quite often. Um, and so there's actually something that people, well, architecture decision records, they're called by different names. So some companies might call them something slightly different. but they generally are the same type of thing. I mean, they might look a little bit different. There's different, styles and things like that, but they generally contain the same type of things. Um, and there's another thing that people sometimes get confused with is you've heard of a thing called request for comments, RFCs?
Yes, yes. I
Okay, yeah.
never,
Yeah.
never wrote them either, but yeah,
Okay. Yeah, so
of
those
course.
those and an architectural decision record are very similar, like in terms of what the information you're giving, or in the information they have in them. And people sometimes get confused as to, like, why do we need both of these? Aren't they the same thing? And um, that's one of those things where it's kind of like the RFC uh, is you're looking towards the future. And so essentially you're basically, requesting for comments, and you're kind of, going back and forth between, arguing things out, and, discussing things, and, having people take a hard look at things, and, throwing stuff out there and getting rid of stuff. And then uh, essentially that's kind of like if you were to take a bill through legislature. It's like you're standing on the floor arguing amongst people about trying to pass the bill and stuff like that. And then the architectural decision record would be, once you pass the bill and you write it into law, architectural decision record's the law, basically. And that's what it is. And then, it's one of those things where you write it, and the people might not always agree with it, or they might, not want to, not have, been behind it. But it's one of those things you can disagree, but then you commit to doing it regardless, because that's kind of what
Yeah.
being a professional is about. So, but in terms of what it has, essentially what it does is it helps codify decisions that you've made in the past about certain major architectural decisions. Essentially, why you're not building this endpoint, or why you're not building the service, or why, something's done this way. And so it does a couple things. One, it gives the reasoning and the discussion around that, yes, we've had this discussion before, so that anyone who, is coming in that's new, or, might have forgotten about it, they can go back and reference the document and read all about it, and everything's in there. And then two, um, it also helps you not have to have amnesia after 3 months, and someone goes like, did we ever talk about this? And then you say,
Guilty.
yes, we can go read this document because the document's over here and we already have it written, and this is what we talked about. Then everyone's like, oh yeah, this is why we didn't do it. So essentially it prevents you from having to relitigate the entire discussion 3 months later, or 6 months later, however, whenever people go back to talking about it again. So yeah, it gives clarity to why something was done, what the decision was, and prevents you from having to talk about it constantly every couple months. So
Yeah, I was found yeah, I think it's pretty, that sounds pretty useful. I thought that maybe that you have some sort of flavor of that, maybe just with Git and recording things in Git, in issues, why, or maybe in Jira tickets and things like that. But the idea, I think, is just the same. I would just, now that you mentioned the RFCs, request for comments, I always found them very interesting. And at the same time, they didn't look so much like request for comments, right? In the way they are written, seems more like this is the final thing. That's it. It's not like one of the things I like so much about Git is just that sometimes you start to discuss something, whatever, and you get all the history there. But when you look for an RFC, maybe because I didn't read so much, that could be the case, but I don't see so much the discussion, which I think maybe in the ADR that you are talking about more, the format, kind of, it's more essential and important, I feel.
right, yeah. From what you're saying, the RFC is sounding more like an actual ADR, but they just called it an RFC. Because an RFC is supposed to be a document that's open for like litigation, or like discussion, or quote unquote arguing amongst the team about, what they want to do. And there's supposed to be things that are changing constantly, like, uh, being updated and, thrown out, ideas added in, and then you come to a final decision, then you create an ADR for it. ADR is basically like the final decision of what, you end up, uh, after you discuss the RFC and whatever.
That might be the case.
But
And I mean, you mentioned something about the trade-offs, and I think that it was also interesting in the book reading about all those trade-offs had to do with some entities that, yeah, the characteristics of the system. And what do you think about these entities, which I found it's a good name I found. Yes.
well, yeah, it's kind of an easy name because a lot of them have the ility at the end: scalability, reliability, security, and so yeah, I think they're kind of just the vocabulary for quality of the system. Obviously, like you're looking at things and want to determine what things are important at the end of the day to building a quality system, or designing a quality system. Um, Ilities are something that you kind of want to know what you're designing for, because you can't have them all at once. So, if you're designing something that's done in 3 weeks, you're not going to probably have like a huge amount of scalability involved in it, because it's a short-term thing that you're building, in a quick to kind of get it to work. So you might focus on reliability and have intentionally put scalability off until a later date when you actually need it. And so I think there's always like an interplay between those qualities. And I think you have to. One of the things that I think a lot of people don't do enough is that they don't decide up front, or I guess quantify up front what they're actually designing the system for. And so, if you don't have any idea what ilities you're optimizing for, then how are you going to get there? And so, if you're intentionally designing for reliability and performance, but you don't actually say that or don't think that, and you just kind of design it however, then it's probably not going to be to the level that you want it to be. And so I think it's very important that you understand what you're actually designing for, and what you're intentionally not designing for when you're building something initially, and when those other things might come into play that you're not designing for. Like if you're not designing for scale, but you might need to be, say, once we hit 10,000 users, then we're going to need to look into properly scaling this a little bit better, or looking to something else to do for scaling. So
Yeah, yeah, and I can think that as you just, I mean, we were just talking about the ADRs. That's what helps the ADR to focus on the things that matters and to agree or disagree and then commit.
yes,
Mm.
exactly. It kind of works together, because you essentially codify what you talk about, and the direction that you're going, and then that way everyone kind of knows what your intent on in how you're designing things is.
I'm gonna put you in the spot here. I'm gonna ask you if you remember any of the entities that you maybe in the last piece of work that you've been working, maybe not the last, and it hasn't that been exactly the last, but if you remember, say, yeah, I remember it was these three, the ones we cared about.
One of the big ones that we've been really focusing on is security, because we've actually been going through some pen testing, and so a lot of the things that we've been doing lately has been to increase security, and that's been a major focus. And that obviously, with AI now, it makes finding it also it helps in both ways. It helps, with writing code, but it also helps in finding vulnerabilities that nobody knew about. So,
Yeah.
in uh, creating things that are secure is always of paramount importance, and I think it's only becoming more important now, with all of the new technologies and new threats that are coming into existence, kind of out
Yeah.
of nowhere now. It seems like every day you're reading about something where a new hack was discovered, or a new, whatever was discovered. And the other thing that a lot of people don't think about is that, almost everyone is using some sort of like third party package, or, like NPM or NuGet, or, and they don't really think about it, but every time you use one, you're essentially bypassing your security and bringing an outside threat directly to you, kind of like a Trojan horse, because um, once you're using that package, if something happens where you don't control that code, if something happens where someone in, a bad actor gets a hold of something, or, a group um, intentionally targets that package and, puts some, malicious code in there, you're basically downloading it right into your system. And it's
So
bypassing it's bypassing all your security features. So the other
you
thing is
mean
that, you find, um, you do scans, and it finds, vulnerabilities in those packages. You have to be on top of that and updating those packages, you know, kind of like around the clock. So I think that's something a lot of teams, really don't think about enough, is that you're introducing vulnerability simply by using third-party packages. And if you're not intentional about your maintenance and upgrading of those packages when vulnerabilities are found, then you are opening up wide security holes, regardless of whatever else you're doing.
are you thinking not only on the packages that you bring to the application that you deploy, or also even your computer, you have brew or npm just to run maybe a component that it helps you to develop but you don't deploy?
Yeah, I mean,
Do you
all of it is. They're all security risks. So you have to balance that with, you better know what you're putting on your computer.
yeah, yeah,
That's why I always see, you read these posts on LinkedIn, or, on X, or, wherever else, and they talk about, oh, I found this cool package that does this. I'm just like, it has like 2 downloads, and you have no idea what this person put in there, and you're putting it on your computer. I'm like, why are you doing this?
yeah, there's risk in there. Maybe thinking about the how the code is great good code. It's I was reading again about the solid principles in your book. It is something I keep forgetting, and every time I read it, I like it, and I find that it is useful to. It's sometimes something that maybe you have somewhat ingrained or learned, some like memory muscle or something, but just talking about them, I always find them that is again useful. So do you remember them? Because I don't remember each one of them. I just remember the solid thing and maybe two or three.
Yeah. Well, S is probably the easiest one that I remember. It's the single responsibility principle. And so,
Okay.
if you've got a class that's doing 20 different things, it's doing this and that and that and that, then, it's probably doing a little bit too much.
Yeah,
Um,
that's the easy one.
yeah, kind of what I, tell the the people I'm mentoring, is that if you've got a class that's doing this, but then you can say, and it's doing that, and if you can use the word "and" in there, then it's probably not following that principle. And you should probably look to do something a little different. So, um, you know, if you got a payment service, your payment service shouldn't break an email notification system. just because, it goes down. So, it's one of those types of things.
Yeah. That's more one of the most natural, I think, that because as you say, that one is easier to remember and to understand, I feel.
Yeah. Then obviously O is open close principle. It's open for extension, but closed for modification.
Mhm.
Um, L is the Liskov substitution principle, which I actually like because it's the only one that's named after somebody.
Yes,
It's named after
yes.
Barbara Liskov, who is a pioneer in the computer science field. I don't know if you've ever listened to any of her talks, but she is really brilliant.
A little
Some of
bit.
the things she talks about, just kind of like how do you like, you know, some of the stuff she talks about is just really like kind of, it's really good, but it makes you think a lot about
I mean,
things.
if you have that principle that it has your name, I think that you definitely
Yeah,
you provide some value, some insights on how things work, like something as essential as to say to a method or to a
yeah,
variable, you
and
can
then
pass. Yeah,
yeah, I mean, obviously that's the subclasses must be substitutable for their base types. So um, then you have the I as interface segregation. Don't force clients to depend on interfaces that they don't implement, which is, I've seen that a number of times where you've got like, um, they don't actually implement the interface, but you have a empty interface in there because the class is dependent on it. And I'm just like, what are you doing? Why is this in here? um,
yeah. I think it comes back to the S a little bit.
yes.
That that it's just do what you're supposed to do, no more,
Yeah,
no less.
exactly. And then D is dependency inversion. Um, Essentially, policy shouldn't or class shouldn't depend on low level details. Both should depend on abstractions. Um, so um, yeah,
Okay.
I think they're good. But I also think that you have to understand what you're designing. If you're designing something like really quick and really simple, like a script or something small, um, I think sometimes people like use that as like a gospel where they try and like over engineer something when you know you kind of have to understand what you're using them for.
Totally.
They're useful, but you don't want to use them in every single situation when, it just adds complexity that's not needed for what you're doing. So,
Yeah. That IDT, you probably don't want it if you don't want the
yes, complexity.
flexibility. Yeah, totally. It happened to me as well when I learned the Gang of Four, all these patterns for object-oriented programming, and that I wanted to apply them
Yes,
everywhere. I was obsessed with it. They said, what is this? Is it a visitor? Is it a template strategy?
factory
And now
patterns.
yeah. So that's a good piece of advice. I would say that that just think about what you really need. And then maybe another thing that I remember reading in the book, which I heard but I kind of never remember so well, is the fitness functions, which is this thing about a little bit. Well, maybe you want to explain it, and you will do a better job
Yeah,
than I can.
fitness functions are actually really cool because they, so you have unit tests that tests what your code's supposed to be doing. Can test certain situations, whatever. Well, fitness functions actually test your architecture that is doing what it's supposed to be doing. So, like, if you are doing like a layered architecture, you can write fitness functions that ensure that you have your layers functioning as they should, and that you're not skipping layers or you're not having upward dependencies or anything like that in there. You can write fitness functions for hexagonal architecture to make sure that um, everything's pointed inward instead of pointing outward, and it's not, um, and so you can write a lot of different functions to test your architecture. And so not only does that help with maintaining the the code in the system, but it also helps in maintaining the architectural integrity of the system. Um, and so essentially, you're ensuring that anyone who works on the code is having to maintain the architecture of the system as a whole. And so I think that's really important because as you get new people and, as time goes on and the system becomes, bigger and bigger and more people are working on it, not everyone has the same ideas or, does things in the same way. And so if you have someone that, doesn't understand the architecture is a new to the system and they try and do something that is going to break the architectural integrity of the system, those fitness functions prevent it. So I think those are, as the system grows in complexity, I think those become more and more important in helping to keep things in line, essentially.
And what would you say that, because I cannot really, I think maybe the fact of how to monitor or enforce is two different ways or two different sides of the same coin in this respect. How could you enforce such a thing? Because I like the idea very much, but I don't quite know how would I implement such a check.
So essentially, you use packages like you NetArch test or like Arch Unit. They're actually like packages that are designed specifically for that type of thing. And so I don't know the exact methodologies of how they do it. I haven't really looked at the code that closely in terms of like what's in the packages and stuff like that. But essentially, it gives you, methods and different ways of doing things that allow you to do those types of things. Uh,
I,
so
um, okay. I think I will try to find more about those packages and copy them now that it's easy to copy if
yeah,
it's open
different
source.
different languages have different. They're different packages, but they're kind of the same thing. I think most languages have those types of packages. Um,
Nice. Good. And here's another thing I was thinking about. Another thing that caught my attention in the book. It was about the what it was called fat controllers and um, anemic domains. Anemic domains. And I remember, how you somehow describe first what a controller is and what when is fat, and then which I find it even more interesting, which I see even more often because I think the see a controller that is fat and when you see too many lines, it's kind of easy to spot. But the opposite, and it goes together as you mentioned. Maybe it's not that easy to spot when you have an anemic domain, and if you can talk a little bit about those two.
yeah. So the fat control, you're right. I think in the fat controller is usually the easier to spot because you look at a controller and you've got like 800 or 1,000 lines of code, and you're like, what is going on in here? And it's it kind of is. I guess that would be like the single responsibility principle applied to the controller because you have, everything
Yeah.
jammed into the controller. You've, business logic, data validation, like orchestration, all in the controller. And, you've got the controller doing too many things. And, essentially it's basically doing a bunch of things that it shouldn't be doing.
Yeah, too many things at
Yeah.
once.
Too many things at once. Yeah. It doesn't need to be doing all that
Yeah,
stuff.
totally.
Separate out in the service, whatever you got to do, but, it shouldn't be doing all that stuff.
Yeah, just the fact that you just said the number of lines that you need to read a lot to understand what it's doing is already telling that it has not
Right.
implemented a single. Yeah. Anyways,
Uh,
and
and yeah, then the anemic domain is obviously, you've got models that aren't really doing much of anything. They're just basically like placeholders or, data holders with getters and setters. But they're not really performing much of a purpose. And yeah, I mean, it's there, but what is it actually doing? That's kind of the thing. Like, what is this? What is this model actually doing? Is this actually doing anything of value? And I think sometimes the answer is no.
Not too much.
And when you can answer, is this doing anything of value? And the answer is no, then uh, I think that you probably don't have enough in there.
Yeah, yeah, and I love the fact that you put them the two together, because I think it helps you to understand how those problems tie together. The meaning, like, if you put too much logic in your controller, you're gonna leave your domain
Right.
anemic, and that's still that maybe take less of your controller, put it on your domain because it is what it belong.
Right. Yeah, you can definitely find a better balance between the two usually, because they a lot of times they go together. You're right, they do go together, because some of the stuff that should probably be in the domain is in the controller, and I think
Yeah.
once you see that and you recognize it and you corrected it, I think things work a little bit better, and you have concerns separated properly.
Yeah, yeah, yeah. I think it's pretty great that you put them both together. It's easier to remember, at least for me, sometimes. That yeah, it happened to me, not uncommonly, that you see endemic domains, but you don't know where to look to say where is look for your file controller, which is nice. Anyways, so yeah, and then maybe a couple of questions that have to do with the hexagonal architecture. And I was thinking, maybe how can you relate them to maybe the layer architecture, and then I would ask you the second one.
Sure.
How,
So a lot of times hexagonal is kind of like a natural evolution from layered architecture. And so if you even go back to like traditional layers, you have the three layers architecture, and then now the more modern layered architecture is kind of like four layers, or even sometimes even five layers. Um, and so it's actually kind of like a midway point between traditional layered and hexagonal, where you actually break a dependency rule, the downward dependency rule in one case, because it points upward in one instance, and essentially you're kind of like at a midway point between hexagonal and layered. You're not fully hexagonal, but you're also a step away from layered where you were. So the modern layered architecture is kind of like a bridge between the two. And then once you cross the bridge, you end up into hexagonal. So it's actually kind of interesting how that works. But I think layered is good up to a point. It helps with when you're first starting a project or an application. It helps create a reasonable separation of concerns and reasonable architectural
yeah.
viable solution. But I think the further and further you go into it, I think you start realizing there's a lot of restrictions that and things that probably aren't gonna work very well in the long term as you keep going. And then I think a lot of teams kind of look to get into hexa, or they take a step towards modern layered, or sometimes they even start at modern layered now, because that's in some ways the traditional layered is considered an anti-pattern now, because of how those layers functioned.
Yeah, 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 that makes sense. I mean, every time that you talk about layer, I only picture MVC, three layers, or front end service and database. That's all I can think of every time I hear that. And then, yeah, the hexagonal seems to me more, yeah, I don't know, to be honest. But it seems to me that, yeah, the way to go is just to put these adapters and ports and what was the dependency injection that you talked about before in the solid one, which are, I think is interesting. And maybe linking that to the next question that I had, it was about, because now I was going to say, yeah, because when I look at the hexagonal architecture, somehow I see in the middle the domain, the DDD, that, which is, well, I don't think it's the same. One thing is domain, another is DDD, I guess. But that was kind of what I wanted to ask, like, how do you see the relation between DDD and hexagonal architecture, if you thought about that, or maybe not?
Yeah,
But
I don't honestly have a lot of experience with DDD. From what my understanding is, DDD is a lot of like business logic type of concerns. But I do know that it's very integrated with hexagonal. It's very closely related with hexagonal in terms of like the functionality that's involved with it. From what I understand, DDD is more about what goes inside of it, and hexagonal is more about how to protect the inside. So it's kind of like what should DDD is more of like what should be in here versus hexagonal is like, all right, once it's in here, how do we protect it type thing.
yeah, it makes sense. It makes sense to me. That definitely, I mean, to put in the DDD, just the business rules. That's what I understand. That when you talk to
Right.
the experts in their what is called the bounded context and the subdomain and domain, things like that. But yeah, it's like how to protect it. I think it's useful to think about that, to say, okay, I have my domain, and from the outside, maybe it's how to protect it specifically, which I sometimes find that if you put this dependency injection and ports and adapters, what is the protection maybe layer that connects the external part with the domain? Maybe that's the key part to get right now that you mentioned. But there you go. So I have just a couple of more questions. That one was one idea that I found. Let me see if I remember. It was this law about Hiram's
Law.
Say that again. Sorry.
Hiram's Law.
Hiram's Law.
Yes.
Yes. That I found. Please tell me a little bit about that, because I thought that was absolutely mind blowing.
Yeah, it's pretty interesting. It was I believe he was a Google engineer, and essentially he said that with a sufficient number of users of an API, it doesn't matter what the promise says in the contract, all observable behaviors of your system will be depended on by somebody. So basically, if you create an API, regardless of how obscure you think you made something, someone's going to use it at some point. And so essentially, that's why once people, a lot of times, I see that with newer developers, they don't understand. They think an API is just a way to connect something together, but they don't also understand that it's actually a public contract. To where once you put an API out there, it has to always stay out there. You cannot ever change it. You cannot ever, remove it. All you can do is version it. So you can change it. You can make it like version 1, and then you create a new API that has different, things in it. You create version 2. And so that way version 1 can always be used by the people that are still not using the new version. And version 2 can be used by anyone that wants to use the new functionality. Because if you change the original version, it's going to break however many people are still using it the old way. So that's one of the most important things that I think new developers don't understand, that it's very, very important.
Yeah, absolutely. And very, very difficult to get right, I feel.
Yes.
When because even if you do version number 2, you would expect that clients that use V1 also can use V2 mostly. But you say, well, I changed this or that, and you always try to move your versions such that you have the least breaking changes
Right.
possible. And to get that balance right is an art. I feel it's really,
Mhm.
really
Now, this is also something other that is part of Harem's law. So let's say that your API always returns results in a sorted order, but it's not because you're sorting it, it's just because your database is automatically returning it in a sorted order for whatever reason. And then let's say later on, like you don't document this. This isn't documented anywhere. It isn't, written about anywhere. But later on, you decide, with this new feature, I'm gonna, change the sorting on it. Well, you're about to break a number of people's, functionality because they're dependent on this undocumented sorting that they've figured out always returns things in sorted order. It's never been documented. You don't promise that, but people are
good.
dependent on it. And so that's another thing is that you're creating unknown dependencies in your own API based on people's assumptions of it that they found are true that you might not even have documented anywhere. So that's another part of Harem's law too. So yeah, that's the other thing that's really interesting.
I remember that one, and that was pretty good. This is pretty amazing. I never think, yeah, working in Google is one of the perks, I guess, that you get to see
Yeah, I
those
guess
things.
so.
And maybe just the last question, like it would be a little bit. You talk about a little bit of Corba, SOAP, and REST, how they come about, and maybe the link between them. And I always find so interesting to understand history because it turns out that we repeat it more often than not. So, can you tell us a little bit about these three maybe styles of creating web services, which I think is chapter 6, I think. I'm not so sure.
Sure. I don't believe I really get into Corba that much. I've actually never even, used it or barely even heard of it, honestly. Like, I found it interesting because I actually had to look up what was going on. And it seems like it was kind of crazy because, from what I was reading, back in the day, you had these cross-language, cross-machine method calls, and they were really complex, and they didn't really talk to each other. So you had one call from one computer that didn't talk to the other computer or the other type of machine, and you had to open these giant holes in your security port because it used dynamic ports. So essentially, they had to open up huge ranges of IP addresses for it to work within, which created security issues for the IT people. They hated it. Yeah, so that was interesting. So that was like the first step. And then it transitioned to SOAP, which was very XML heavy and very
Yeah,
hard, honestly. Like I've only dealt with that like very, very rarely, and I hated it, to be honest with you. It's it was crazy.
it was verbose. That was
Yeah,
for sure.
very verbose, very complex, very mistake prone, I found. Just um really something that was greatly improved upon by REST, I think, because REST is essentially works the way the internet works. Essentially, it's built for the internet because it uses the same rules as the internet uses, and so I think that was kind of a natural evolution. Um,
Yeah, I don't see anybody doing SOAP anymore. That is for
no,
sure.
except on very old systems, or if there's a very specific reason.
Yeah. Although in the Corva side, I think that we are back to the RPC with gRPC. Somehow they fixed the ports. I feel now you have this port that I think that didn't happen again.
Yeah.
And yeah, well, that's kind of it. I don't know if I didn't ask you any questions you would like me to ask, or any thought that you would like to share.
Um, the one thing that I'll say is that I think just in my opinion, I think especially with new developers and new people coming into this field, they spend a lot of time these days, trying to learn about AI and like the best, models and the best this and the best that for AI. And I think they're doing themselves a disservice because I think what they should be learning about is the fundamentals of software architecture and software engineering. And I think there's not enough focus on that these days. And I think it's going to really hinder their ability to actually use AI because AI essentially only accelerates what you are. So if you're a good engineer, it accelerates your ability to be a good engineer. If you don't have fundamentals down and you don't understand fundamentals, it accelerates your ability to create chaos in a code base. And
Mm.
so, I think more people would be better off learning fundamentals of software architecture first and then worrying about AI second.
Yeah, I couldn't agree more. It's a multiplier.
Yeah,
So
exactly.
yeah, and I think that your book definitely it will help with that. Like it's an easy read with a lot of good info. I found. So well, I guess that's it, Matt. Thank you so much for coming around
Yeah,
and
of
sharing
course.
your time in a day like this.
Yeah, of course. It's been fun. My pleasure.